Hello, welcome to this part. So in this part, we will take an example of a simple truss and we will solve it. We will try to find out the forces in the member of the truss. So this is the first example. It says determine the force in each member of the truss as shown in figure and indicate whether the members are in tension or in compression. So we need to find out forces in each member of the truss, and the truss is this one. So now you can see this truss is composed of three member AB, member BC, and member AC. So we have to find out force in all three members. So now we have two options. First, uh, to calculate. Now, first step would be to draw the free body diagram. So if I make the free body diagram in the same truss, then you can see this is the hinged support. So it will offer two reactions. Say this is the one reaction, say A, Y, and the second reaction would be horizontal reaction. So I am just taking the direction of this reaction randomly, say left to right, and I will name it as AX. So AX means reaction at A in the X direction, reaction at A in the Y direction. Similarly, at point C, it is a rocker or roller supported. So it will offer only one reaction, which is vertical. So I'm assuming that it will be vertical upward reaction. So I'm naming this as CY, which means reaction at C in the Y direction. So I'm taking Y as vertical axis, X as horizontal axis. So our first step is to make the free body diagram. So now I have made the free body diagram of this truss. I have shown the reactions in this, and force is already shown in the diagram. Now, uh, second step it is to find out the reaction. Now, if we want to consider joint A, then we need to find out reaction, these two reactions first, then only we can use joint A to find out the force in member AB and member AC. Similarly, to, to use the joint C, in the joint C, force in member BC, force in member AC, and reaction CY. All three are unknown. So in that case also we need to find out the reaction. Then only we can use joint C. Now we have another option that we can consider joint B. And in joint B, there are two members AB and BC. Only two unknown member which suffice the condition that I have discussed in the procedure, that we will choose only that joint which will be having unknown member not more than two. So first option, either we calculate the reactions first and then we start our analysis by taking joint A and then C and then B, or second option is we take joint B directly and start determining the forces in member BC and BA. So I think the shorter way would be to take or to consider joint B first. So that is what I have written here. Since we should have no more than two unknown forces at joint and at least one known force acting there, we will begin our analysis at joint B. Why? Because one known force is already available here, and other two forces, which is along member AB and which is along member BC, they will be unknown. So we can consider joint B. But before considering joint B, we need to assume the force in member BC and AB. We need to assume the sense. So initially, I am assuming that member BC is in compression and member AB is in tension. So now if I make the free body diagram of joint B, it will look like this. So now you can see this is joint B and this is the force and FBC is showing the force in member BC, and the sense, now you can see sense is towards the joint B, because I have assumed that in the member BC force will be in compression. So that is why I have assumed, I have already assumed the sense, so the sense would be towards the joint. Similarly, I have assumed that member AB will be in tension. So that is why the sense, or this arrow, force BA, this arrow is pointing away from the joint. So this is the sense of tension and this is the sense of compression. So now we will consider joint B and we will apply the equation of equilibrium. So first equation is summation of fx should be equals to 0, and also we will follow the same sign convention that we have followed in lecture 2. So as per that, the force along the left to right, it will be considered as positive, and force along right to left, it will be considered as negative. Similarly, if there is an upward force, it will be considered as positive. If there is a downward force, it will be considered as negative. So first we will consider the first equation. Now first equation means all the forces along the x direction, their summation should be 0. So now in the joint, there are two forces which are along the x direction. So if I consider this is as x direction and this is as y direction. So along the x, there is this one force, and the second force is horizontal component of FBC. So horizontal component of FBC will be negative because it's negative. Its horizontal component will be like this. So it is negative. And this one is positive because it is left to right. So I will write the equation. So there I have written 500 Newton minus FBC sine 45. So horizontal component of FBC is minus sine 45. So now if we solve this equation, we can find out the value of FBC as 707.1 Newton. And you can see the value is positive, which means I have assumed the sense correct. I have assumed earlier that member BC will be in compression, and that is why I have made this sense. And according to my assumption, the value of FBC is positive. So I will say that the assumption is correct and member FBC is actually in compression. Earlier I have assumed, but now I have proved that it will be in compression because my value is positive. Similarly, I will now apply the second equation, which is summation of Fy. Now, second equation, according to second equation, upward force will be considered as positive. Now, in the same joint, if we apply this equation, then we can say that force FBA is vertical, is along the Fy, and similarly, the vertical component of FBC will be along the Y. So we will find out that. So FBC cos 45 will be taken as positive because the vertical component of FBC will be upward. So it is positive. Similarly, the value of FBA, because I have considered sense in member AB as tension, and that is why the arrow is pointing downward. So according to that, FBA is taken as negative. And now if we solve this, you can see we have already calculated the value of FBC. We will put that value here in this equation and we will find out the value of FBA as 500 Newton. And you can see the value is positive, which means the assumption that I have made in member AB is correct, which means the member AB is under tension because my value is positive, so assumption is correct. So with this joint B, we have calculated force in member BC and member AB now. Now we have to find out force in member AC. Now, to calculate the force in member AC, we have two options. Either we consider joint A or we consider joint C. Well, we have to consider joint C because in the joint C, we have vertical reaction as unknown force. We have force AC again as unknown force, but the third force, which is FBC, it will be known now. But if in case of joint A, there will be unknown force AY, there will be unknown force AX, and there will be unknown force AC. In case if we consider joint A. So that is why this time we are going to consider joint C. And also I have written here, since the force in member BC has been calculated, we can now proceed to analyze joint C to determine the force in member CA and the support reaction at the rocker. Now support reaction is this one, CY. I am taking this as CY. So again, so you can see this is the joint C, free body diagram of joint C, and force in member BC is already calculated, which is 707.1 in the previous slide. Now I am assuming that in member AC there will be tension force. I am assuming this, and because of this assumption I have shown this FCA as arrow which is pointing away from the joint C. So which means the member, I mean force in member AC, I am assuming that it will be tension. And now I will apply the equation of equilibrium at joint C. So applying the equation of equilibrium, we have summation of fx equals to 0. Now we have two forces in along the x direction. One is FCA, which will be negative, and horizontal component of this force, which will be taken as positive because its horizontal component will be left to right. So writing the equation, now we can find out the value of FCA as 500 Newton in tension, which means our value is positive, and it means that our assumption is correct. I have assumed that member AC will be in tension and value now is positive, which means assumption is correct, and member CA will be in tension. Although now it is not required, but if we consider joint A, we can even calculate reaction AY and reaction AX because force in member AB and force in member AC now we have calculated. So although it is not required, but we can calculate that. So for that we will now assume joint C. Okay, sorry, I forgot. Uh, if we apply second equation, so in that case, second equation will be uh, reaction CY. So it is upward. So CY is taken as positive. Similarly, the vertical component of this force will be 707.1 and it will be downward. So that is why it is taken as 707.1 sine 45. And now if we calculate it, we will find Cy as 500 Newton. So as I said, it is not necessary that but we can determine the components of support reaction at joint A using the result FCA and FBA. So to find the reaction, now we can draw the free body diagram of joint A. And in this free body diagram, we now know the value of FBA and value of FCA. So with these two values, we can find out the value of AX and AY very easily. So now again applying the equation of equilibrium, we have summation of Fx equals to 0, and in this case, FCA is taken as positive, AX is taken as negative, and AX will be 500. So the value of AX will be 500. So horizontal reaction at joint A, the magnitude of this reaction is 500 Newton. Similarly, we can use another equation which is summation of Fy, and in this case 500 Newton minus Ay. So FBA is positive, Ay is negative, so whatever. So in that case, Ay is 500. Now, one more thing. Here, the force is showing, reaction force is showing downward. Earlier, I was showing the arrow as upward. So if I made this upward arrow here, then my value would be negative. But if we take this arrow downward, value is coming positive, which means the reaction would be downward actually. So this, the reaction at A would be downward like this. So earlier I have made this upward, so that upward reaction will be negative. So this value is positive because in the free body diagram I have considered that this reaction will be downward. So based on this, we have done this calculation and value of Ay is 500 Newton positive. So our main aim is to find out the forces in the member, which we have already done. Now we have to show the result in the figure, and that I will be showing you like this. So we can say that member BC is in compression, member AC is in tension, and member AB is in tension. And their magnitude is also shown here. The tension force is 500 Newton in member AB. The force 707.1 Newton here and here in member BC, and force 500 Newton and 500 Newton in member AC. So this is how we can show the forces in each member by showing their nature, whether they are in compression or in tension. So that is the solution of this truss. So in the next part, we will take another example. Thank you.